In Russia, the first standard submarine carrier of Zircon hypersonic missiles, the Yasen-M project submarine Perm, has been launched. What does this mean? Why did the missile get this particular name? Where is zirconium metal mined in Russia? And why is global competition for it intensifying? We'll talk about this as well as the feat of the week in this episode after a brief summary of positive news. The Soyuz 2.1, a launch vehicle with the crewed transport spacecraft, successfully launched from the Baikonur Cosmodrome. A KSP-01 crab fishing vessel was launched at the Krasnoye Sormovo plant. At the Stakhanov ferroalloy plant in the Luhansk People's Republic, the fourth electric furnace was launched after 11 years of downtime. Production of gearboxes for industrial robots has begun in Chelyabinsk. Production of the first Russian payment terminal has started at the Inferit plant, and in Ivanovo, there is a high-tech foundry. The Vulcan plant has expanded the production of rubber technical products, an oil plant has opened in the Orenburg region, and a poultry complex has opened in the Vologda region. Russian school children won 6 medals at the World Chess Championship in Serbia. At Sevmash, the fourth serial submarine Perm of the Yasen-M project has been rolled out of the slipway. In total, our Navy currently has 5 multi-purpose nuclear submarines of these projects: 885 and 885M Severodvinsk and 885M Severodvinsk, Kazan, Novosibirsk, Krasnoyarsk, and Arkhangelsk. But Perm differs from its predecessors in that it is designed to be able to carry Zircon hypersonic missiles as standard. Certain changes had to be made to the design for this, which delayed production somewhat, but it paid off by increasing combat power. The ship-based launchers are unified with the launchers for the Universal Medium-Range Anti-Ship Missiles, Onyx, and the Caliber cruise missiles. That means the enemy will never know what kind of strike our submarine is preparing to deliver. And not just it. Although Perm became the first regular carrier, all her sister ships in the project also gained the capability to use Zircons. And that means their total hypothetical salvo could be 192 missiles, each capable of carrying a nuclear warhead. Let's add here the submarines of Project 949M Anti and the surface carriers. And we can roughly imagine what kind of threat to the enemy is posed by just the naval component, and only with this type of weapon. On December 3, 2024, the Russian Federation Navy put on a colorful demonstration for NATO observers in the Mediterranean Sea. The crews of the frigates, Admiral of the Fleet of the Soviet Union Gorshkov and Admiral Golovko, carried out launches with hypersonic Zircons. This means that despite the secrecy surrounding the missiles, we are no longer afraid to publicly demonstrate their capabilities. However, the demonstration launches did not provide any clarity to foreigners, and all public data about the capabilities of these products is still speculative. There is a certain hint in its very name. Zirconium is a metal named after the mineral zircon, and it has high hardness, a high melting point, and resistance to corrosion. There is no exact information about whether it is used in the missile of the same name, but it would be quite natural. As is known, hypersonic weapons and objects moving through the atmosphere heat up to temperatures of several thousand degrees Celsius. Zirconium oxide is a ceramic material with high heat resistance, traditionally used in thermal protection coatings for aircraft engines and spacecraft. It is possible that it is also used in the nose cone or body of the Zircon to protect against overheating. Zirconium is also added to heat-resistant alloys based on nickel and titanium to increase their resistance to corrosion and temperature stress. Therefore, it is likely also present in the missile's engine. But let me emphasize that all of this is just speculation. However, zirconium also has some other properties that make it indispensable in other important fields, for example, in nuclear energy. After our country launched the world's first nuclear power plant in 1954, Soviet scientists began to focus on improving the efficiency of the stations. To achieve this, it was necessary to replace the stainless steel in the fuel rod, claddings, and other reactor core elements with a material that had lower neutron absorption. Zirconium became the ideal candidate for this role. Not only is it strong and heat resistant, but it also has the necessary neutron transparency. Since then, it has become an indispensable structural material for nuclear reactors, power plants, and naval nuclear installations. In addition, zirconium releases a huge amount of heat and light when it burns. Its powder is used in tracer bullets, illumination rockets, and incendiary munitions. It is also added to alloys to increase the strength and heat resistance of military vehicle armor, and zirconium oxide is used in stealth technology to reduce radar visibility. According to some reports, the Zircon missile is equipped with this very technology, which once again indirectly indicates the use of this material. All of this is known not only to us, but only a handful of countries have zirconium reserves and know how to process it. The largest zirconium reserves are in Australia, South Africa, Russia, and China. In our country, the main deposits are the Kovdorsko deposit in the Murmansk region, the Tugansko and Rasipno deposits in the Tomsk region, as well as several others. At the same time, huge reserves and resources of zirconium are concentrated in the nepheline cyanites of the Lovozero ultra-basic massif on the Kola Peninsula, where this metal is part of many minerals. But it's not enough to have reserves. You also need to be able to turn them into a final product. Today, only Russia, the United States, Canada, France, China, and Japan have a full cycle of zirconium production. In our country, it is carried out at the Shepetsk mechanical plant in the Republic of Udmurtia. And this is one of those pleasant cases when we don't need to catch up with anyone. We already have the necessary resources and technologies, and we know how to produce zirconium with a purity of 99.95% for the nuclear industry. Recently, it became known that another project will be launched in the Murmansk region to develop zircon bredolite ore deposits, from mining to processing. Here, they will extract not only zirconium, but also rare earth metals. The total ore reserves are estimated at more than 20 million tons. Nowadays, this is becoming a significant factor in geopolitics. So in response to Trump's tariffs, China this week imposed controls on the export of so-called heavy rare earth metals. The controls apply not only to the rare earth elements themselves, but also to their compounds and finished products. This will make it harder and costlier for Americans to source raw materials for producing missiles, satellites, and other high-tech goods. That makes what we have on our own native land even more valuable. Let's get back to the nuclear submarine Perm. In 2026, it will join the Navy and become the 6th submarine of the Yasen-M project in service. 3 more of the same type are under construction, and 3 more are being prepared. This is real power, and as we've shown, it's provided not only by rare resources, but also by the technologies for processing them. New deposits and production facilities guarantee that Russia will not only maintain its leadership in the zirconium race, but will also continue to set the tone where others are forced to catch up. We will keep you updated on the events. Next, about the heroes. In the Yamal village of Kalyasavi, a 52-year-old man lost control while riding a snowmobile, and after hitting the handlebars, suffered a serious injury, a ruptured intestine. The paramedic who arrived, Stanislav Konovets, realized that urgent surgery was needed and called for a medical helicopter. But that day, A blizzard was raging, and all flights were suspended. There was no time to wait, so Stanislav decided to act. He borrowed an all-terrain vehicle from local residents and drove the injured person himself through the blizzard to the nearest settlement, from where the patient was then taken to the Neuebursk hospital and successfully operated on. It turned out that Stanislav regularly saves people in this way. Just this year, he has successfully evacuated injured people in need of emergency help 3 times, risking his own life and traveling dozens of kilometers in bad weather. This is what true dedication to one's work and patriotism looks like. We thank Stanislav for his heroic deed and wish him good health.